All right, welcome to the after work video. A little bit of a late start today, so I'm going to go until 6:30, maybe even 7 if I'm feeling it. Hopefully I'm feeling it. Yeah. So yeah, I have my temperature thermostat program to incentivize me to leave the apartment around 6. So it might start getting pretty hot in here from 6 to 7, but let's see here. Okay, so where we left off last, we were going through kind of with a more fine-tooth comb to look at the traffic that was sent. So with a cron job, it all rebooted. So we lost the live captures, but that's okay because we can still get a sense of what the traffic was with the captures that we had up from before. So one thing we'll notice, so this is the connection to the PE from the CE. So it's between the PE and the CE where it goes there. We're going to notice some big differences in the routes that are exchanged. So here's a yeah. So here's an update, here's an acknowledge. So let's find an update similar to this one, but in the link between the P router and the PE router. Okay, so here's one of those kinds of links. We can tell that it's like that at first glance because we've got RS-VP traffic, that sort of thing over here. We're not going to have that over those other links. So let's put on a filter for OSPF traffic. Here we go. So now we've got the same LS update. So let's open that up and take a look. Okay, so this is interesting for me to see. I wanted to see this because I was actually thinking there might be a different kind of update because it's in a VPN, but nope, it looks like it's pretty much the same. One thing I would be interested in seeing is the BGP traffic. Another thing, just kind of a way to use Wireshark better that I could have done is I take this LS update. So now I can see open shortest path. I want to find packets like this, so I can do apply as filter selected. Oops, but it looks like this is actually specific to, yeah. So I would want this to be applied as the filter because it's not specific to the actual traffic here. I just want to flag it based on the general kind of traffic it is. So if I use that filter, I could have made my life a lot easier because OSPF-LSA equals 1. So this is a type 1 LSA, router LSA, but it includes extra routes. Yeah, so it's always interesting to take a look at the traffic. Let's look at BGP traffic. Okay, I think there's a way to filter out keep alive too. Yeah, so this type, I could do apply as filter and not selected. So all BGP messages that aren't hellos. Okay, so let's try that on the other captures. This one, obviously, it's not going to be there because it's the C to the PE. Yep, not going to be there either because we just didn't have any updates. So one thing I would like to do is, yeah, just set up this filter on all of the captures. Well, actually, I'm going to close all the captures and I'm going to bring the lab up again, and then I'm going to make a BGP update policy because there's just one point I want to really kind of drive home and be more comfortable with, and that's the fact that we're no longer exchanging just plain old IP routes. Now that we've got it in a VPN, they're going to look different. So I want to call that out and bring attention to the fact that what is actually going across the wire is different now that it's in a VPN. Okay, so let's open up PE2, and then we'll sniff this link here. Okay, and then apply the filter to it. Oops, so it looks like I lost the filter, but I remember what it was. We're just going to take all of the, so we're going to filter out. So we want, we do want BGPs though. So we're going to be do and BGP like this. There we go. So now we're going to get all BGP messages except for hellos, which are the only messages we're getting right now. But we will get update messages once I trigger them, which I will do. Okay, so let me trigger these messages here. Okay, so we'll get some withdraw messages. There we go. So I'll roll that back right away so we get the messages where they're added as well. So we'll get two more popping up here shortly. I think, unless the bug happens where it's no longer capturing. But I think this is all we need because I just wanted to show that the NLRI, network layer reachability information down here, okay, so yep, this is why I'm looking this up, because I guess I was expecting it to be a certain way, but it's not that way. So that's important to learn how it's actually going to be. So here we've got NG-VPN, but I was expecting the actual routes to have the route distinguisher somewhere. I mean, clearly the destination source is not going to be in there, but I was expecting the actual network layer reachability information to not be IP addresses, but to be VPN addresses. So it would have it would have the route distinguisher prepended. Oh, it looks like it does have the route distinguisher, so I think it kind of is what I was expecting to some extent, because I was expecting there to be the route distinguisher and an IP address. So it looks like what I was expecting to be there is in fact there. We can see it right here, but it's just the way they are shown in Wireshark is differently than how I was expecting them. I'm expecting them to be more similar to what you would see in the routing table. Let's take a look at that. Okay, and we can just look at it on PE2 because it's going to be similar to what's on PE1. Yeah, so this is what I was expecting to see there. You can see they're showing up special. So let's just take a look at all of the different kinds of routing tables I have. So let's do show route table, question mark. So I've got the BGP L3VPN table. I've got the NVPN table. I've got regular old INET, and then I've got a second INET. Got INET 3, MPLS. Then I've got these custom tables. So I'm drowning in tables. It's definitely getting out of hand as far as the tables go. But you can see a lot of the custom tables .1 are just simply for multicast. So where's the other more custom one? And then of course we've got our VPN tables. So you can see really all you get with a table is you either get different instances of routes. So here we have just our regular routes here, and then here we have our special multicast routes. So we've got two of the same kind of table, but one is populated with our special multicast stuff, and the other one's populated with just our regular routes. Now you can see we've got a similar thing going on for INET.3. We've got path. We've got a /32 here, which is the other side of our LSP. So INET.3 is typically used to verify MPLS. And then, of course, we've got our INET.0 table here. So these are all INET tables. So we're going to see IPv4 addresses. But in addition to INET tables, so here's our final INET table here, and this is for our, it's a .1 for our multicast. But INET tables aren't the only kind of tables you will have. You also have MPLS tables here, so you can see we no longer have IP addresses in them, we have labels. Here we have an L3 VPN table, and you can kind of follow along with the syntax. So here's the name of the table, here's the type of table, and here's the instance of the table. This is kind of similar to that. This is BGP L3VPN.0. So these are all going to be BGP routes because that's the signaling protocol I'm using for my L3 VPN. But one thing you can notice is that this is no longer an INET table. So just as in the MPLS statement, in the MPLS table, my statements within my table are going to be a different syntax than my INET table, because we're not dealing with INET in the MPLS table, we're dealing with MPLS labels. The same thing is true for my L3 VPN table. We're not dealing with INET, we're not dealing with MPLS, we're dealing with L3 VPN, which has the route distinguisher and then the IP address. So this is what we're exchanging. We're not exchanging this, and we're not exchanging this. We're not exchanging INET, we're not exchanging MPLS, we're exchanging L3 VPN. So hopefully this is starting to click. If not, I think this makes it the most clear. IPv6 obviously needs its own table. It's completely different. So we call that INET6. INET6. So the same thing holds true for NVPN. It's its own table, and we can see the syntax of that is kind of similar to just L3 VPN, but we've got an extra field in the top there. So, and then we've got it for IPv6 as well. So yeah, hopefully that makes sense. And let me know in the comments if it does not. We've got table names. We've got table types, and we've got table instances. So this section here is going to determine what shows up here. To some extent, this will turn up, will show up what turns up here, but you can see, oh, well, it's a BGP. Why do we have a MVPN route in a BGP? Well, this is just the name. The thing that's actually more descriptive of the table itself is this middle entry here, because you can see, yeah, these are what's popping up here. We're not seeing IPv6 routes. We're not seeing IPv4 routes. We're not seeing labels. We're seeing these special MVPN routes. Which I'm surprised are showing up. Oh, okay, I can see these have a longer mask because they're for IPv6. Okay, so that was good to look at, because I'm sure I'm going to be looking at these tables, and looking at them for the first time in the exam would have been really bad. So yeah, definitely, I think doing a good job so far, I hope. Oh, I'm very, very concerned about this test. I was concerned about it before all the problems in the United States. Oh. Okay, so let's pull up the Wireshark capture again. There we go. We'll remove the filters just to get a better sense of everything that's on there. And I want to verify that it is, in fact, no longer scrolling. So let's see if there's a 206. Now, there should be a 206 in a few seconds, because those OSPF hello packets are sent out every 10 seconds. So, nope, yep, it looks like for sure it has stopped scrolling, because I'm sure it has been more than 10 seconds by now, and we did not see a OSPF hello message. So I forget what link it was. Oh yeah, it's this one. All right, so everything looks pretty good. Let's go and look it over some more. Yeah, really nothing of note that I can think of. I guess I'm not used to really seeing the details of an RSVP packet. I don't even really know what to look for. Let's just filter out for RSVP and see the different kinds. So we've got hello messages, we've got, oh, it looks like so far we've just got hello messages. Let's do a filter out for the message type, so we can know for sure. Okay, yep, so they're for sure, we know for a fact that they're all hello messages. Otherwise, there would have been something popping up that was just an RSVP message, but not a hello message. So, I mean, one thing we can do is bounce the link and see this pop up. I'm kind of curious enough to do that. But the problem with that is the capture has stopped. So I need to restart the capture. You know what? I think I am curious enough to do that. One thing I might consider doing is marking this topic complete and then moving to the next one. Or marking this complete, ending the video, uploading it, moving to the next one. That might be a good idea. Okay, so here's RSVP. So here's the hello. Yep, so let's do a filter. We'll just prepare not selected, and then we'll do collapse all this, and then do apply as a filter and selected. There we go. Oops, but I think it stopped capturing. I think it usually stops capturing like if you tear down an adjacency, if you shut down a link, if you do something like destructive, I think it stops capturing when that happens. Yeah, let's just verify if it did in fact stop capturing. So we've got our OSPF hellos. The last one was 10 seconds, 13. So yeah, it definitely would have gotten a hello by now. So it for sure stopped capturing. All right, well, that's too bad. Let's take a look at the configuration. Okay, and the next examples. So here's a PIM SSM provider. So lots of examples. I don't think I'll need to get this down in the details. I might. It might be good for me to go through all these examples. I'm really not sure. But I think I am going to stop this video here. I'll mark it off. So I'll prepare yeah, because I'm going into the 6th video anyway, which is kind of a lot of videos for a topic. So yeah, this is going to be a shorter video. It's the 6th video. I'll just put this on there. This is probably the best resource for this. Well, actually, let's as part of this video, let's go see if there's an inet.0 resource for MVPN. Ah, there is. There's a really good one. Okay, so I think I am going to have this video go out longer then, and I'm just going to read as much of this resource as I can about MVPN because I think this is a wonderful resource, and I think this is going to be a really good use of time. But this is definitely going to be the very last video in this topic. But Yeah, so this is Understanding NG-MVPN. This article will present you how to configure NG-MVPN architecture based on RSVP P2NP as provider tunnel. Additionally, Juno supports several provider tunnels, aka P-tunnel. Those are listed here. So I believe the one we used in the example, because we did use a particular kind of provider tunnel. So I don't see anything about a tunnel. So we definitely, here we go, configuring the provider tunnel. So we used RSVP TE. Let's take a look at the different kinds of tunnels that are available. So let's go to PE1, that is where you would configure one of them, and then go set routing instances, VPN-A, provider tunnel. Okay, and these are all the tunnels that are available. So hopefully this will align closely with the INET write-up. So yep, this is the one we went with. So it's number 1. Then we've got multicast LDP with point-to-multipoint LSP. And I think that's what the rest of these, yeah, so I think a lot of these are configuring this with a different kind of provider tunnel. Yeah, that's what's going on here. These labs are so that we're using a different provider tunnel. So one of the things I might get on the test is set up a NG-MVPN using tunnel type 5. I mean, if I get that, that's just going to be ridiculous if they can't even tell me the name of the tunnel and they only give me the tunnel type number. That would just be, I think, unfair. But being able to troubleshoot or configure one of, handle any of these kinds of types, I think it's definitely going to be fair game. I think it's more likely to be this first one here than any of these, but multicast is a big part of the exam, so it could be any of them. Yeah, so doing all of these probably would be worth it, especially since they're good practice for understanding VRFs better. But as I said, I really got to keep my self on task here, and I can't spend too much time on any one topic. So we'll just look for these. So RSVP-TE, point-to-multipoint, LSP for flooding. We've got a PIM-SSN provider tunnel, PIM-SM. So yeah, we can see the lines there. Here we will cover the P-tunnel type 1. So they don't even have a write-up for the other kinds of tunnels. So I think it's pretty clear that it will be the type 1 on the test. If it's not, hopefully there's like a help apropos, because they'll give me a different kind of, so let's say they give me this tunnel, I can do help apropos here. Oops, and I've got to do, of course, a pipe match help. Oops, and I may need to do a run. Okay. Yeah, so it looks pretty straightforward. I'll be able to use this help extensively. So I'm not too worried about any curveballs. I just want to be able to read and understand the information. That's my number one goal, is to be able to manage my time and not spend too much time just hopelessly confused. Like even time going through the help and reading the help is better than time like having a meltdown and just sitting and thinking. I mean, that's going to be important to some extent, you know, just kind of taking a deep breath and, you know, taking a minute or two to just think and organize my mind. That's definitely going to be important, but the more commands I have seen, the more output I'm familiar with, the better I'll be. Here we will cover the P-tunnel type 1, RSVP-TE, P2MP, LSP, and we will consider that multicast streams will be SSM, source specific multicast. We will consider that receivers know the source address of the multicast streams. There is no RP in this topology. The concepts of NG-MVPN is quite simple. We will keep at the edge between PE and CE routers the PIM protocol. At this level, we speak about C-PIM protocol, C for customer. C-PIM allows to exchange join-prune information. PE then converts those information in BGP via a new NLRI. Moreover, at the data plane level, between PE and CE, we keep native IP multicast forwarding, but within the provider network, the IP multicast is conveyed in what we call the provider tunnel. The provider tunnel could be inclusive or selective. It means inclusive tunnel. All PE are connected to the P tunnel. It means that all PE will receive the multicast streams convey within the P-tunnel, even if there is no receiver attached to the PE. Selective tunnel, a subset of PE are connected to a dedicated P-tunnel. Only those PE will receive multicast streams. We will focus only on the inclusive tunnel mode. The rest of the article, we will refer to this topology. As you can see, our core network is made of a single ISIS area with LDP/RSVP protocols enabled. So usually you do one or the other, RSVP or LDP, so I'm not sure why they're saying they have both. As far as I understand it. Oh, I see, because they're using LDP for the MPLS transport layer. They could use RSVP there, but they went with LDP. But they're using RSVP for the provider tunnel. And as we saw before, they did have more options than just that. Let's see what options they have. Oops. So set routing instances, VPN-A. Okay, so set provider tunnel. So they do have an LDP option? That's what I was curious about. Do they have the option to use RSVP or LDP for the provider tunnel? Yes, they do. As you can see, our core tunnel is made of a single ionized area with LDP/RSVP protocols enabled. We have one CE acting as a multicast source, CE3, and 2 receivers, CE1 and CE2. The route reflector peers with all PE, provider edge. The BGP NLRIs exchanged are the following. As you can see, we will exchange PMSI, P-multicast service interface routes, and also classical L3 VPN routes. Hereafter, the BGP configuration of the route reflector. The global BGP configuration is the same for the 3 others PEs, except they only peer with the route reflector. Okay, so we see we got a special family for the MVPNs, for VPNs. We've also got this cluster that's, because it's a route reflector, it's going to need that. Now let's move on to the configuration of the 3 PEs. There are 2 configs. The PE3 is a sender site. Unlike PE1 and PE2 that are receiver sites only, the configuration is done at routing instance level. Routing instances are classical VRF instance. We just add the multicast service inside. The configuration of the PE3 is the following. Okay, so this is going to point to that route reflector. So unless this is the, I guess I'm a little bit confused which one this is. Yeah, so this is the, okay, no, it's the route reflector. That it's pretty obvious just by the content of the config that it's the route reflector as well. So we can see the routing instance here, VRF, protocols. I guess I would have expected there to be a neighborship to this address here through BGP, which I don't see that, so I'm kind of surprised that that's not there. When you enable NVPN on a VRF routing instance, you need to add the knob VRF label table. Okay, well, that's interesting. Did we add that? So I'm pretty sure we enabled NVPN on a VRF routing instance. Let's take a look. So yep, we definitely enabled NVPN on a VRF routing instance. We can see type VRF. We can see protocols NVPN, but we don't see that VRF label table. So what was it again? Set table label table. Set VRF table label. Okay, so yeah, we're missing that one. Let's see what it does. This knob allows 2 things. The first one is the allocation of a unique label per VRF, not per prefix as default. The second one is to allow a double lookup after the decap action. Indeed, without the knob in cap without the knob in cap, data coming from the provider network is only decap and forwarded O. Without the knob, the in-cap data coming from the provider network is only decap and forwarded to the right interface connected to the VRF. The per prefix label allocation allows to do that. But for multicast, the P tunnel, the router needs to update the multicast routing and forwarding tables of the VRF. So it needs to analyze the packet carried in the tunnel. The VRF table label allows to do that. As PE3 acts as a sender site only, we specify that explicitly to avoid unused states and to scale more. The multicast source, which is not directly connected to the PE3, actually this is the LO of the CE3, needs to be explicitly known on PE3. This is why we add a static route to allow PE3 to know the source and accept multicast traffic coming from this source, RPF check. Finally, as PE3 is connected to multicast source, we need to define the P tunnel configuration. Here we simply define the P tunnel as RSVP TE P2NP tunnel. As remote PEs will be discovered dynamically, we cannot define statically the leaves of the P2NP tunnel. We only configure an LSP template that specifies the global parameters of the RSVP LSP. Each time the PE3 will discover dynamically a remote PE via BGP PMSI type 1 route. RSVP-TE will graft the remote PE to the P2NP LSP via RSVP path message. So it will first, the remote PE2 will auto-discover BGP NLRI I-PMSI type 1. And then number 2, use LSP template, add PE2 to P2NP LSP RSVP path message. The LSP template is defined in the MPLS section like this. So we definitely have this in our configuration. We didn't have that label table, so I'm surprised that it worked without that, because it said that was very, very necessary. But I'm pretty sure we did have this configuration here. So let's take a look at that. Edit protocols MPLS. Label switch path. So yep, we got 2 PE, so show pipe display set, pipe no more. Yep, and we've got quite a different configuration here. We just have this statement to that other side. We don't have it set up to be used as a template. We don't have the P2MP. We don't have the no CSPF. So yeah, it's kind of interesting to me how different what we have is from what was shown in this example. Now let's analyze the configuration of the 2 receivers, PE1 and PE2. The configuration is very simple. The knob VRT table label, VRF maybe, is again mandatory to allow the double lookup. And we configure the 2 sites as receiver site explicitly. In this case, the P-tunnel configuration is not needed. So let's look at what I've got again. Yeah, so we're missing that receiver site as well. It's time to check our VRF routing table. as we use the VRF target to assign statically import and export RT, by default, all routes within the VRF are advertised via the family inet-VPN unicast. Let's move on to the VRF routing table of PE2. You see that PE receives 3 BGP routes that are this one and that one. 1.1.1/32, the multicast source sent by PE3, which known it via its static route to X/30 subnets. So these two here, which are the CE/PE interco from PE1 and PE3. At this step, we can consider that all the 3 PE know the multicast source, PE3, directly attached to it via the static route, and PE1 and PE2 remotely via the BGP route sent by PE3. Here, there is nothing in relation with NVPN, only classical L3 VPN configuration. Now it's time to start the NVPN signaling family of PE2. When PE2 becomes up, it means when it joins the VPN topology, it first sends a I-PMSI AD route. Okay, so here's an example of that. And I believe we saw that in the capture, because that's the thing that I just remember. Well, I don't know, it's all a blur to me at this point. I'm hoping that the test won't require such in-depth knowledge. It'll just and to be honest, I'm hoping I can use the help apropos strategy I've got. I hope that'll get me out of 1 or 2 jams, because there's just so much content on the exam. I don't know how comfortable I can get with every possible what are they called? I don't even remember. Provider tunnel configuration. How can I get comfortable with every single possible flavor of configuration for every single possible topic on the exam? It's just too much. So I'm just hoping if it comes down to that specific, I can just take advantage of the show or the help apropos and get out of a jam that way. So this is the originating router loopback address. So this is originated by all PE routers participating in NG-MVPN. Then we've got this section here, originating router RD, route distinguisher. Yep, so this is a valid route distinguisher where you can see we've got the 2 parts to it. They chose the syntax that has a IPv4 address in the first part. And then this here is the route type. Yeah, and we do have those in the routing table for MVPN. Oops, yep, discard them. Show route. So as I showed before, we do have a MVPN table, and the routes within it look almost exactly like that. You can see they're a bit shorter because I decided to use the autonomous system and not the IP syntax. The type 1 route is sent via a BGP NP-NLRI AFI:1 SAFI:5. It sends its router distinguisher as a unique identifier of the PE. The next hop of the route is the primary loopback address of the PE. Hereafter, the CE-BGP update, which conveys IPMSI type 1 route sent by PE2 and received by PE3 via the route reflector. Okay, so here we can see that it is type 1 IPMSI. On PE3, you can check VPN routes in the MVPN.0 table of the routing instance. So, yep, this is what we did. Our routing instance is named VPN-A, but yep, we definitely checked this table, and we've only got these 1: routes. As you can see, PE3 has got 3 MVPN routes, its route, and the 2 other I-PMSI type 1 from PE1 and PE2. It's really as PE are multicast neighbors. Anyway, it is how Junos considers this MVPN relationships to show the PE3 MVPN neighbors. When PE receives the PE2 I-PMSI type 1 route, it triggers a RSVP path message toward PE2, the NH carried into the I-PMSI type 1 route. Next hop, I'm guessing. So we're getting the NH, that's going to be a IP address, because I think that means next hop. I guess I don't know what NH means. It never defined it. You can now check the P2MP status, first on ingress PE, which is PE3. You can see that the same label is assigned to the 2 remotes PE, which are PE1 and PE2 loopback address, label merging. And you can check on the transit P router, PE2, the state of the P2MP LSP. Here you can notice that there is a replication, the first onto PE1, onto P1, never mind, to reach PE1, and the second one toward PE3 to reach PE3. The label out is different. Great, all our PEs are now enabled, and the P2MP LSP has been set up after the auto discovery phase via the I-PMSI type 1 routes exchange, but there is no multicast stream yet. It's time to bring up our multicast source, which is in our topology on CE3 to simulate this given SSM multicast stream. We use this trick on Junos very usefully, very useful. Oh, okay. Oh, that's cool. So we can simulate a multicast stream. Don't forget to specify a TTL value. By default, it is 1. The command generates a 10 PPS, packet per second, multicast stream towards PE3. On PE3, we can check the multicast routing table. Okay, so let's do that on our lab here. So we've got a, so let's go first of all back. Okay, yeah. And we've got our topology here, so it's, yep, it's going to be right here, and it's going to, there we go. So yeah, we've got a multicast set up here, so let's go on the CEs, because I think that's where we're going to need to run that. Okay, so we'll do CE2, and then we'll start a multicast stream to CE1. Okay, so we're going to ping 232. Oh, well, we're not going to ping 232. We're going to ping 224. Okay. Okay, so it looks like we need to specify the interface. I'm not sure which interface needs to be specified, but I'll do the right-facing interface. Let's see if there's a explanation about it. Okay, so this is going to be the source interface. So let's specify okay, well, let's use the loopback interface for this. Or isn't there a, let's here, show configuration interfaces LO0? I thought there was an LO0.1 interface, but let's just specify the loopback interface for this. Okay, and then for a source address, so that's interesting that, okay, so the source address of the echo request, I'm not sure if that can be the same, if it has to be different, but let's just try making it the same. I'm going to do a TTL 64, interval 0.1. Oops, so we've got no route to the host, unfortunately. I thought we did. I don't know what's going on with that. Because I thought we had multicast going. Oh, you know what? Well, let's see here. Show route. No, I don't see it here. So I think I will see it on the PE. Well, but it's meant to be on the CE, so yeah, kind of strikeout for me. Don't forget to specify a TTL value. This command generates, okay, yep, so that. Well, shoot, I guess I can't get that to work. Oh, there's not that much more to read, so I'll just get through all this. And then unfortunately, even though I couldn't get that to work, I'll need to move on. The multicast stream is well received and accepted. RPF check thanks to the static route. But as you can see, its forwarding state is still pruned. Indeed, remember there is not yet receivers up on PE2 and PE1. In this case, the multicast stream is silently discarded on PE3 and not forwarded through the P tunnel. Now we add a receiver connected to PE2 to simulate that we simply add a IGMP version 3 static group on CE2 to force CE2 to send to PE2 a PM join for the multicast stream. When PE2 receives this PIM join, it first check its unicast VRF routing table to find which is the source of the multicast stream. In our topology, 11.1.1.1/32 has been sent by PE3. PE2 then converts the PIM join in a PMSI type 7 route. Type 7 example, source tree join route. So we don't have any of these on ours. That could be why it's not working. Originated by the receiver PE router, the PE that receives a local CS/CG join message, or the PE that already has a type 6 route and receives a type 5 route. I just want to verify I'm still learning about MVPNs because this, yeah, okay. Oops. All right, so here's the breakdown of everything. So it doesn't look like, it does still have a route distinguisher. Okay. Here, the BGP update sent by PE2 to PE3 via the RR. All the PE participating to this MVPN topology receive this update via the RR, but only PE3 takes into account it because it is mentioned in the update via the RD field of the I-PMSI route. On PE2, you can check the status of the PIM conversion. You can see which S:(G) streams are active and on which RSVP P2MP tunnel they are mapped. Let's move back on PE3. We can check the MVPN routing table of the VRF to see the PMSI type 7 installed route. When PE3 receives this route, it starts to forward inside the P- tunnel, the multicast stream matching the I-PMSI stream parameters here 11.1.1.1 and 232.0.1.1. We can confirm this by seeing back the multicast forwarding table of PE3. Great, the forwarding state is no more in pruned state, and we can have on the downstream interface, which is actually the interface where the P tunnel is routed. We can see on PE3 that the P2MP LSP now conveys multicast packets. On transit node P2, where the replication takes place, you can see also the LSP statistics. You can see that the stream received from P4 is forwarded to P1 and P3 to reach PE1, which has no receivers, and P2, which has got receiver. To be sure that the bandwidth is well used, I mean that PE3 ingress PE sends well one copy of the MCAST stream along the path PE3, P4, P2, and that only P2 replicates the stream. I'm checking the interfaces statistics on P2. We receive 10 PPS from P4, so the PE3, from PE3 the ingress PE, and we forward those 10 PPS to PE1 and PE2. Remember, with inclusive P- tunnel, we flood the stream over the P- tunnel. So PE1 that doesn't have receiver receives also the stream via its provider interface, but PE1 will do not forward this stream, and this one is silently discarded. You can check this behavior by analyzing the multicast routing table of PE1. The forwarding state is in pruned state. Unlike PE1, PE2 has got receiver and its forwarding state is different. PE2 forwards the multicast stream on PE002.0 interface, which is connected to PE2, the receiver. If PE2 leaves the stream, it sends to PE2 a PIM prune message. This prune message is converted by PE2 in PMSI type 7 withdraw route. As we are in L3 environment, the withdraw routes are conveyed as NP unreachable NLRI. Hereafter, an example of BGP update sent by PE2 when it wants to prune the given. Conclusion, this chapter do not cover the selective tunnel configuration, which allows to have specific P-tunnel for specific multicast stream. Moreover, we considered here that multicast sources are well known. In some configuration, this is not the case, and you need to add, for example, SSM-mapping on PE, acting as RP router. Also, INET Zero's JNCIE-SP workbook contains excellent NG-VPN practice scenarios. So you can see why I'm really questioning whether or not I want to go forward with this exam. This is literally probably one of the best resources I've found on this. I mean, the official documentation is decent too, but you could see they completely screwed up how to set this up, and I had to just troubleshoot it and figure it out how to do it myself, which is a good skill to have, yes, but you know, I can be doing, I've actually got some Amazon Kindle books right now that I was working through before, but I actually stopped doing that. So I could be continuing to work through my Kindle books. You know, I wouldn't be having to read these sorts of things that are just full of really kind of fractured English. And are for a really specific scenario that I would never really encounter in the real world. Whereas if I would just complete my Python for DevOps book, my Mastering Python Networking book, even though this book kind of sucks too, or even just a Python cookbook, or pick up some new books, you know, that I think would be more valuable to me. But unfortunately, doing that wouldn't be backed by a major vendor like Juniper. From what I understand, employees can even get discounts or extra credibility if I have that certification. So as of now, that is the plan, to go through that, but it's just kind of discouraging whenever the best resource I have is a resource like that. All right, so that's going to be it for this topic. So I will mark this as done. Okay, and then the next topic we'll look at will be eVPN, and then we'll go back and start doing it in order before. So as always, let me know in the comments if there's anything in the curriculum that would help you out. I can definitely go out of order just like I did now. There's no problem with doing that. And in fact, we saw here that actually helped me out because I got more practice with it, other things. I got practice that I was long overdue for. So, okay, so this is now done, but we're not going to be continuing with this. We're going to be moving to VPNs, and then eVPN, and then going back through the regular order. So the next will be BGP. And I think we can just basically rush through this whole thing because I really think my series for the 961 on BGP is pretty darn golden. It's probably unwatchable as hell, but as far as what I learned from it, I feel pretty confident with BGP right now. So MPLS, however, though, I do not feel very comfortable with MPLS. So yeah, so I think doing it in order will be totally fine. Thanks for watching, and I will see you in the next video.